Okay, so welcome everyone. We are very excited to be joined by the SageModeler team for part 2 of an introduction to SageModeler, taking it really to the next level. We really appreciate the time, Dan and Tom and Steve and Lynn, that you are offering our community. We are recording the session, so folks who do not make it can benefit. For those who don't know STEM Teachers NYC, we are a small organization, but a very big community of STEM teachers in the New York City tri-state area and growing. We offer professional development workshops for teachers, all developed and led by teachers across grades. We started in 2011 and have just continued to grow. So the way that we're gonna use our time today, the SageModeler team, Dan and colleagues will lead us towards kind of advanced level stuff and a new way, I think Dan said, of trying out dynamic systems. So part 1 was an initiation into static systems. And Juliet and Autumn, who are 4th and 7th grade teachers at the Chapin School, are actually going to share some of their insights and scaffolding and how they've used SageModeler with their students already, and have quite a few examples of student work to share. So I guess without further ado, I'm going to hand it over to, Dan, do you want to say a word before Juliet and Autumn get going?
Just for those of you who I haven't met yet, I'm Dan Damlin from the Concord Consortium. We're a nonprofit group. Most of our work is funded by National Science Foundation grants, a few private foundation grants, and our goal is to try and research and develop best technologies and techniques for teaching science. And I have a couple other colleagues here with me. Steve Roderick, maybe you can wave, and Lynn Stevens and Tom Farmer.
Go ahead, share the screen. Everybody, they were wise enough to have the same SageModeler logo in the background. We're working on it. So yeah, so we're gonna start out actually really through examples, real world use of SageModeler. Juliet's gonna share how she's been developing it and introducing and developing it with her 4th graders. So maybe you can introduce yourself a little bit.
Yeah, absolutely. My name is Juliet, and I'm on the board of directors here at STEM Teachers NYC, as well as a class 4 science teacher at the Chapin School in Manhattan. If you were here last week, I talked a little bit about how I was looking to use SageModeler with my 4th grade students in our distance learning environment, modeling severe weather systems. And I gave you an example of a model that I had created as an example of what students could create. But today I'd like to talk about the actual work that the students have created and a little bit about how I supported and scaffolded them in that work. So I'm going to share my screen. Okay, so we started off this unit browsing some different resources that were kindly provided to us by our librarian at Chapin. And I had students just do some general research on different types of severe weather. So we had hurricanes, tornadoes, extreme precipitation and floods, drought, and extreme heat. And after browsing through those resources, they had to come to a decision on which type of extreme weather they would want to commit to and continue learning about. So this student chose extreme precipitation and floods. This is a 4th grader. And the way I scaffolded their research was by giving them a note-taking tool, which would then help them with the creation of their model. So I gave them, for each source that they reviewed, I gave it a number, And then I would ask them what the name of the source was, and some of them even put the link so that they could revisit the source later on. And I asked them to share at least 3 of their main takeaways from the source. So we talked about how a takeaway is something important that we literally want to take away with us. We're not going to remember every fact that we read in the article or every fact that we heard in the video, but we want to make sure that we can at least go back and figure out what was most important. This student was an overachiever and definitely did more than 3 takeaways for this source. And of course, for each source that she reviewed, she went through the same process. Now, after I had them review about 4 sources, I encouraged them to review at least 4 sources, or if they felt that they, at some point in their review process, felt that they knew enough about the causes and effects of their type of severe weather, then what they could do is move on to listing some causes of their type of extreme precipitation, of their type of severe weather. So this person is extreme precipitation and floods, some of the causes. And then we have some effects of their type of severe weather. So this person did effects of extreme precipitation and floods. This, so the notes scaffolds this, listing the causes and effects. And now this causes and effects work that they've done over here is going to support them in the creation of their model. So I wanted to show you a couple of different examples of models that the students are in the process of creating. We're still in the middle of this process. We're by no means done. So many of these are works in progress, just FYI. So the student is also studying floods, and she created her model so that she had all of what she felt were the causes of floods on one side and the effects on the other. And then she created these relationships to show that, you know, an increase in precipitation could result in a flood, and that a flood could result in disease, damage to crops, death, destruction. And if you go to the simulate option, you can see that if you increase the amount of precipitation, you're going to have a greater number and severity of the floods. And then when you have a greater number and severity of floods, you're also going to have more of these negative outcomes. So we're still working on this, but this is what she has thus far. This student has not worked on qualifying any of her relationships yet, but she came at this a little bit differently. She's doing drought, and she has 3 causes of drought: climate change, overuse of water, when too much water evaporates. But what she did differently, which I thought was really interesting, was she made her effects these different chain reactions, right? And so drought leading to illness or to conflict or to you know, socioeconomic issues could, you know, all lead to these similar outcomes. And I thought that was a really interesting way to do that, and a different perspective than in the last model. This person did a hurricane. We have our causes: moist and humid air, ocean water, and then we have some of our effects. So again, destruction, pollution. So you can see that this is very similar to this one, but this one, she has not yet qualified her arrows yet to show what the relationships are. This student did drought. Again, she labeled her causes, her effects. If we go to simulate, and let's say that we exacerbate all of these different factors, if we increase every single one of these different causes, our severity of the drought, or the amount of time that we have a drought, is going to increase, and so are these negative effects. Again, these are all in progress. And then another one that looks kind of more like a flow chart where she did actually make all of her arrow relationships. And just another example of a different perspective. Like, none of these are right or wrong. They're just different ways of looking at the same system. So it's interesting to see all of the different angles that they could come at the same assignment with. Yeah, so those are just some different examples of what my students are working on. They're fourth graders, so we're going slowly. What I asked them to do first was really just show the relationships with pictures and arrows. I didn't ask them right away to do this, which is, if I double click on this arrow, an increase in precipitation causes floods to increase. I didn't do that the first time I explained this to them. You know, they just had the pictures and the arrows, and then we learned afterwards, what do we do with these arrows? What do these arrows mean? So that was another way that I scaffolded this activity for them. But they seem to be really enjoying it, and I'm looking forward to what comes next.
Thank you, Juliet. That was really great. A really interesting and a variety of approaches, but also interesting to see where you can really start to see how students are unpacking their own thinking about things.
Absolutely.
It's really great.
How are you thinking of concluding it? And, you know, like, I really appreciate how you took us through the steps that got the students to that stage. Where do you end it?
Yeah, so, you know, I realize that none of their models are going to be quote unquote perfect, right? They're going to have flaws. What I really want them to understand is not necessarily quantitative relationships, but qualitative relationships between these different variables and factors. And what I'm going to have them do, because, you know, one person might have been focusing just on hurricanes and one other person was focusing just on droughts, I'm actually going to have them do like a virtual gallery walk of each other's models, and then after doing that gallery walk, answer some questions so that it also allows them to get an idea of all of these different weather systems. And then we're going to move into a discussion, which I already, as you can see if you saw in the note-taking document, which I already started scaffolding, which is, okay, now how do global warming and climate change perhaps exacerbate or relate to instances of severe weather and severity of severe weather.
That's great. Thank you. Can we hand over to Autumn? Do you want to introduce yourself? If you have questions for Juliet, please drop them in the chat, and she can answer them, and we can also pull for them in a shared Q&A towards, you know, as we move along in the conversation. But let's move to Autumn.
Okay, hi everyone, I'm Autumn. I teach with Juliet at Chapin. I specifically teach 7th grade science, and what we've been working on, as I mentioned during the first workshop, is we're working on an astrobiology unit. So we started the unit by talking about the needs of life here on Earth, and students did an investigation, which I'll share with you in a moment, where they studied what mold needs in order to grow and what affects the growth of mold, and they used SageModel to make some predictions about the data that they were going to collect for this experiment. And where we went with this was, after they collected their data, shared it with each other, and built their models, we're now discussing other planets and what is present on other planets and what makes a planet habitable. So let me share my screen, and I'm just going to take us mostly through kind of how I introduced this program to my students, because the first time I introduced them was through this like distance learning setting. So they had already designed experiments where they were investigating one factor that they thought was going to affect the growth of mold, and they were doing these experiments at home. And so what I had them do was I made a video, and I shared the video with them through Google Classroom, and it introduced them to SageModeler. And what I asked them to do was to basically model for me their experiments and how the factor that they were investigating they thought was going to impact the growth of their mold. Sorry. And then what I gave them to start with after the video was just like this blank canvas that had mold growth on it. And then they had these pictures that they could drag and drop. So like, in addition to just incorporating their own variable that they were investigating, they also wanted to incorporate some of the constants. So I had them include all of the needs of life that they thought the mold needed. But what they had to do, which you'll see here, is they had to show me how their variable was going to affect the growth of the mold. And so, for instance, if the student was investigating how water was going to affect the growth of the mold, they had to identify the relationship between water and mold growth. They had to explain to me why they identified that relationship as being what it was, using their understanding of science. And then what they did was, after they built their models, was they actually tested their models. And this document here has a few questions that I used to kind of get them to think through that. So they're, again, telling me what was the independent, what was the dependent variables in their experiment that they also included in the model itself, but then they had to run their model and they had to identify if the data that they collected from their initial run matched the predictions that they had made for what they expected to see in terms of the growth of their mold. And to do that, they pressed the simulate button and they collected, it's just qualitative data that they're collecting, like more or less growth, but it worked for what we were doing, so that was great. And what we did was, after the students let their mold grow for a couple weeks, they collected their data and they had each investigated different factors that may have affected the growth of the mold. And so they shared their data with each other. We had a class discussion about the data that was collected. And what they had to do is they had to revise the models based off of the data that they collected and the data that their peers collected about what factors had affected the growth. And so even if they had just investigated water, when they went to revise, they had to make changes to their model in terms of all of the needs of life and how they all affected the growth of the mold. So this is on the screen now an example of a student's revised model. And so they, again, they could work off of what they started with, but I told them the relationships needed to be adjusted if need be. So some of the relationships they got to keep the same, some of them they may have adjusted a little bit, and they also had to explain to me why they had adjusted the relationships if they did, or why they had selected what they did in terms of relationships. And the final thing that I had them do after they made their revisions was I had them just identify some merits and limitations of the model that they made using SageModeler. So having them think about, in what ways does this model accurately reflect the experiments that they conducted, and in what ways is this limited in what it can demonstrate in terms of the data that they had collected and shared with each other.
This is really great. Thank you, Autumn. My question is to both of you. You said that your students were sharing their data with each other. And Juliet, you said that your students were doing a gallery walk. Can you share just a little bit how you did that? I mean, it's connected to the tool that they were using, but how exactly were they doing that? Oh, you're muted.
We're going to do the gallery walk next week, and the way I'm going to set it up is very similarly to the way we have it in the agenda document for this webinar. I'm going to put the links to all of their models in a document for their class, and then they're going to be tasked with taking some time to kind of individually check out other people's models, think about them, and then we've been using Seesaw as a platform with the fourth graders, and I am going to create a couple of things on Seesaw. One where they can provide a response about what they learned from looking at all of the models, and also a way for each other to kind of give each other feedback on their models as well. So that will be through Seesaw.
Thanks.
And for me, I had students prepare a slide that they presented to their peers in kind of like a gallery walk, if you will. I put them in breakout rooms in Zoom, and they shared their poster that they had prepared through Google Slides. And the poster included like what was their investable question, what were their variables, what data did they collect, and what conclusions did they make. And they shared those posters with each other in these breakout sessions. And then as they were sharing with each other, they then got the opportunity to like record some notes that I had them record about what each other had investigated. And it was helpful also for students who investigated the same variable to also see that sometimes the data looked a little bit different depending on what materials they had available at home and depending on what kind of bread, among other things that they did differently.
Thank you. That's great. Thank you both. Lots of thank you. So.
Yeah, no, there's a couple questions in the chat. One, sharing of the explanation video. I assume that's to you, Autumn.
One more time, what was that, Tom?
Sharing of the explanation videos.
Oh, sure, yeah.
Are you okay with that?
Yeah, I think I just have to download it on my computer and put it onto my other Google Drive because I don't think it'll work if I give you the link through my school email. Okay. But yeah, I can definitely do that. And
can you put that on the agenda?
Sure, yeah.
Okay. And the other was a question about Seesaw. And you said a little bit about that.
Yeah, so the way I would describe Seesaw, it's not completely analogous to Google Classroom, but I call it like the Google Classroom for younger students. I'm teaching fourth graders, and it's just a really great way to post assignments, and then instead of them having to figure out how to upload, photos and video, it gives them the opportunity right in the app to record video or take photos, so that the upload process is really easy. It also, it doesn't have to necessarily be a video or a photo. There's, ways that you can have a writing assignment in Seesaw as well. But I've just started using it a couple of weeks ago because of distance learning, and I feel like it's a really great tool.
And I'm going to address the data question in just a second, unless there's other questions that people have for Autumn or Juliet.
I think that sounds good. I think we're good. Okay. You can keep adding. Yep.
All right, so I'm going to share my screen and continue to feel free to add questions into the chat. We'll try and field those as they come along. Okay. So I'm just going to start with this last one that Autumn was showing. If you go into Simulate, if you want to get data from the simulation, you can see that we can adjust these various factors and see how things happen here. If I want to, I can record one data point and then adjust the slide or record another data point, but generally you might want to just record continuously and say, okay, well, what if I have a lot of solar energy, or if I go down to a little bit of solar energy? You can see data is being generated in this table here. I don't really need the table right now, so I'm going to close it and I'll stop recording. And if my question was, how does solar energy affect mold? I could click this little graph icon here, and it shows me of all the data points I collected, what were the mold values. But what I really care about is, as solar energy changes, how does it affect mold? And then I can see this relationship here. So more solar energy, less mold. And if they have their own data, and it depends, I don't know how they quantified it or qualified it in terms of descriptions. You could, if it's quantified in a particular way, you could actually put it, create a new table in here of your own data and type it in. Or you could just use, whatever you're already using for dealing with data and compare any graphs you might generate there with the graphs your simulation is making. And then you could think, oh, well, maybe I need to adjust a relationship, or maybe I'm missing some key variable that's part of my system. All right. So from here, one of the things that I wanted to do, we were going to have folks, we were going to give people an opportunity, for those of you who created some model of your own. So if you have, you see these share links here that Autumn and Juliet put in. Well, you can create your own share links to any model that you've already been prepared or been playing with. Does anybody want to share their model? I'll remind people quickly again how to do that. So if I were wanting to futz with this model and change, the layout or add a new thing or change some relationship here, then I could do that. And I'm not affecting this person's model because I have a copy. It's a share link. And to get there, I would go to the menu, go to share, get link to shared view, and then I can enable the sharing and copy that link. Now, once I have that, if we go back to the agenda, you'll see it says, share your models below. So if you click on that, it's going to jump you down the page. And I can say, Dan's modified model and put that in here. Oops. There we go. And so I'm wondering if people did any work between the last session and now that they want to share, or if people made something new, or they just had something that they wanted to share with the group and ask a question. I'll give people a minute to decide if they want to put any share links down in here. It's just if you scroll down from here, you'll be able to paste some share links in here.
I'm seeing some of the same names. Alan, did you get a chance to keep working? Or maybe Kamisha? Sorry.
I think I may have done one little tweak to it after the meeting, but I have to find my way back to it. I got a lot going on the screen here right now, so I'll try to put it up.
So it looks like in the chat again, possibly just one more time. If I go into this menu next to where the document title is, I go to share. And if I haven't shared yet, it'll just say share here or get link to shared view. And then I can enable it and copy my link. That's the way to share your stuff so that everybody gets a copy and isn't trying to work on your original document. We'll wait one more minute. If there's nothing else that people want to share right now, what we can do is we can move on to the next part.
Dan, would you just be able to quickly show the difference between the default settings and the basic relationships?
Sure. So in this model, actually, I can't go back to basic because some of the more expanded relationships are used. So let's make a new one. I'm going to go to that same menu and say new. And I'm just going to put a couple variables on here, A and B, and connect them. And if I go to do the relationship, so I can double click on this or double click on the arrow or click on this and open the relationship panel. And you'll see here that I have, an increase in A causes B to, and increase, decrease, or vary. So there's lots of options here. If I choose one, then I have a whole bunch of different sets of relationships that I can define. If I changed this to basic over here, then when I come into my relationship panel, the only option I get is increase or decrease. So for younger students, or if you want to just simplify the workflow, most things can be characterized as like, as one goes up, the other goes down, or as one goes up, the other goes up, or one goes up and the other goes down, that kinds of thing. You can just use the basic relationships. And those settings, how you want to set up the canvas for the students, you can do that here before creating a share link to your document that you send out to students. They modify, do things, and then send share links back.
I use the basic settings for fourth graders because I felt like it would be more digestible for them.
All right, well, we have one shared model here. Let's take a look at that one quickly, and then maybe Alan, you can talk a little bit about your model here or any questions that you had. This is a climate change or global warming model that you started last week. Oh, I think you're muted. Yeah.
Okay, all right. So Got a lot of windows going on a small laptop screen, so I'm sorry. So I think I had about, some of this was there last time, and this time I just thought of, adding a secondary effect. So think dust in the atmosphere. I thought there would be some albedo effect or whatever, some sunlight reflected off the dust. And then I thought, okay, what would cause that? Because during our conversation, I got the impression people thought it was, maybe pollution from cars or whatever. But if there was a big volcano and that spewed a lot of ash into the atmosphere, that might increase the amount of dust and actually decrease the temperature. So I was playing with that. And the other two, forest coverage and car emissions would have opposing effects on the carbon dioxide level, which would trap heat in. So I was just trying to look at, a little bit more.
Great. There's a question about, can you collaborate on a model? So this isn't like a Google Doc where two people could remotely work on something. You could, so one of the saving options, so if I wanted to save this, I can save to Google Drive. And this is, this is my base level Google Drive and folders in my various Google Drive. And if two students had access, read and write access to the same folder, they could potentially at different times, not synchronously, because it would probably mess up if they tried to edit the file at the same time. So that could be one way to do it. The safer way would be for a student to do some work, pass the share link on to another student, and they do something and pass the share link back. They could pass a share link back and forth each time, make a new one, and then turn in the final share link to their collaborative work. But in terms of synchronous collaboration, like a Google Doc, you can't really work that way. At least that's not how the software is designed to work right now. All right. I'm going to move on to talking about, oh, it looks like we might have one more to share, or a couple more to share. So I'm gonna pull up, Jen, we'll pull up one of these. Is there one that you prefer?
The car speed, I think that one of the Stellar Core tries to use collectors, and the car speed, I was trying to do force equals mass times acceleration and trying to get acceleration to work, and it didn't quite work. So those are both in progress.
All right, well, let's take a look at it and see if we can get a sense of what's going on here. So we've got a lot of different connections here. So aerodynamics of the car affects the air resistance, which affects the acceleration, which affects the speed, which affects the air resistance, which affects the acceleration. So one thing I see here is you've got a feedback loop. And so this, one of the things that, and this is actually a good model to look at in terms of segueing into some more dynamic systems and collectors, because some of the things that people are, one of the things that we want to talk about today is how do you decide about whether the model should be in this, what we call static equilibrium simulation or dynamic. I see you made this dynamic, although I don't think anything is a collector in this. Oh yeah. There's, oh, right here's a collector. Actually, this looks pretty good in terms of you've got acceleration, and the speed is a collection of the accelerations over time. And as the speed goes up, it causes an increase in the air resistance, which reduces the acceleration. So there's some interesting stuff going on here. One of the things I think is happening is a lot of stuff is happening near the beginning of this. And one thing I want to point out is you could reduce the number of steps the model calculates, and that will kind of focus in on the earlier ones. And sometimes you have to increase those steps. I'm going to take this as a segue to talk about dynamic modeling and what the differences are. Because in order to understand this kind of model, you have to understand the differences between what we call static equilibrium modeling and dynamic time-based modeling. So I'm going to jump back over here, and I'm going to start with a simple epidemic model. So it's quite simple. And as with the bulk of all of the simulations you've seen so far, all the models except for Jen's have all been static equilibrium simulations. And if we look at this, I've got infectivity of disease, the number of contacts affects the chance of a contact being infectious, and that will affect the number of infected people. If I simulate this, you can see I can adjust these things, and I can see that there's various things that affect how many people get infected. Now notice this is not, there's a lot of talk about flattening the curve. There are no curves here, right? This is a kind of instantaneous result. If you have certain inputs, these are the values for the outputs. In many ways, a static equilibrium model is like a visual spreadsheet in which this cell is calculated from these two cells and this cell is calculated from that, but it provides a much more visual way to represent your ideas. So what would we do if we wanted actually to understand what's going to happen in the course of some kind of epidemic or pandemic like we're in now? Well, in order to do that, we actually need to think about what's happening over time, right? So static equilibrium models, they're really good for like these things affect that thing and this is the result. Dynamic time-based models are for behavior over time. So I'm going to change this to a dynamic time-based model. And I want you to notice what happened to the graphs. They're all lines now, but they're basically behaving like bar graphs because over the 30 steps that this model is calculating, nothing changes. The infection rate stays the same, the number of contacts, or the infectivity stays the same, the number of contacts stays the same. So these are just calculating a single number again. What we need is a new kind of variable that remembers its value from the previous step. And I'm going to turn off the simulate so we can look at the icons. And infected people is the thing that's going to change over time, right? This is something that's going to go up or go down, however we set up our model. So I'm going to select infected people and go over to here, and I'm going to check the box for it to be a collector. Now I want you to notice what happened here. See that it went from a single one thing that represents a value to a collection of stuff. And it disabled that original relationship I had because we have different kinds of relationships that we now set when we go to point to or come from collectors. And I'm going to look at this relationship now. And if I look at this, it says chance of contact being infectious is added to, subtracted from, or sets the initial value of the infected people each step. And if I change steps to days, it'll say each day or something like that. So you can think of it that way. Now, if I read this sentence, it doesn't make a lot of sense to me. The chance of a contact being infectious is added to the number of infected people. So that might actually give me a clue that I might want to put something in here that would be a little better. I'm going to pull this off of here and say, I'm going to call this new infections. So now chance of contact being infectious is going to affect new infections, and new infections can be added to infected people. So another way to use those relationship panels as a scaffolding to think about how you're designing your model, and even what the names are of the variables that you're using, because we want to make sure all of these variables are something that can change or be calculated from like a low to high scale. So I'll say an increase in chance of infections causes new infections to increase about the same. And then I'm going to come over here and say new infections is added to infected people each day. All right. Now I'm going to push simulate and let's look at what happens. All right, we no longer have just straight bars across all of these. Our infected people goes up over time. And we can, again, still look at number of contacts, affects things and how it affects the steepness of the curve of infected people, or steepness of the slope of this line here. And so I've got my first, my first foray into a dynamic model, which is showing the behavior over time. Again, key thing are these collectors. If you don't have collectors, then nothing's going to change over time. Now, if we want to get to, let's say we want to get to this idea of flattening the curve or seeing something generated like the charts that people have been looking at for what's happening with the pandemic over time, then I have an interesting thing that I want to think about. Well, the infected people is one collection, but where did they come from? Right? They came from the susceptible people. And in fact, what I'm going to do is I'm going to break this link here and say that I've got my infected people and the new infections are being added to the infected people and they're being subtracted from oops, I have to make susceptible people a collector as well. I'm going to turn this off here so you can see I made that a collector. And new infections is subtracted from susceptible people. And now I can say my chance of contact being infectious affects new infections. I could leave that there. In fact, I could have left that. I should have just left that the way it was. And I'll put that back to the way it was. An increase in infections causes new infections about the same. And now if we go to simulate, we'll start with lots of susceptible people and very few infected people. And we can adjust this. So we see that this is acting as a way to transfer people from this collector to this. But in fact, it's a little bit awkward to say I've got a variable that's like going from here to over there. It'd be nice to say we've got a flow from the susceptible people group to the infected people group. And in fact, there's a way to do that. So I'm going to delete new infections here. And we're going to see a new kind of relationship by connecting two collectors together. If I go to that relationship, it says susceptible people is, I could say added to, subtracted from, or transferred or converted to infected people each day. Let me turn off this simulate for now so you can see the icons. So notice we have our susceptible people. We've got a pipe going through a valve to the infected people. So now this is saying a certain number of susceptible people will become infected each day. If I open the simulation, the valve is what controls how fast that happens. And basically, if I want to connect this back up to what I was thinking about over here, infectivity, number of contacts, chance of contact, well, the chance of contact becoming infectious is what affects my rate, my valve, how far open it is. And so now I can say an increase in the chance of contact being infectious causes flow from susceptible people to infected people to increase, and I'll say about the same. So now I'm back to this interesting kind of model where I have a collection of susceptible people. They end up in the infected people group. I have some things that I can try out to affect that. We still don't quite have those kinds of curves that we see in our real world behavior, right? So why is that? Well, that's because in the real world, there's some feedback going on within the system. So one piece of feedback is this idea that susceptible people, well, we don't have the same number of susceptible people over time, right? If we had lots of susceptible people, there's more people who are available to become infected. So I'm going to say that the susceptible people affects the rate at which more people become infected people. If I have more people in this pile, then more of them become infected. And in fact, that's what the relationship looks like. More susceptible people means more will be transferred to infected people each day. Let's try that now. And we're starting to see some of the kinds of curves. They're getting closer to what we would see in the systems that we've been looking at. And
Dan, to clarify, can you use the water flowing out of a bucket model to describe that last relationship you used to the valve?
Sure, I could. So if I had, I'm going to actually talk about it as sort of first of all, I want to talk about what the valve represents, and then we can look at it in another, maybe simpler context. But the valve itself is a value that says how much to transfer from here to here, each step of the model calculation. As Tom wrote in the chat, it's a rate. How fast does it happen over time? I don't know if you've noticed in a bathtub, for example, if I had a, you know, my water in the tub and my water in the drain, and these two are collectors, and I make this the transfer. Now, one of the things, I don't know if people have noticed, have you noticed when the tub is really full, it drains faster than when it's getting near the end? And that's because you have more water pressure, right? The level of the water is higher, it's pushing harder on the drain, the water goes out faster. So in a sense, it's saying that the amount of water in the tub is going to affect how fast the water goes into the drain. And if we look at that, if I set that relationship, so more water in the tub means more will be transferred to water in the drain. We're not doing days this time, but it has that. And we can see if I put water in the tub, we get water in the drain. And we see this pattern here of a decreasing time based on the amount of water. So as there's less water in the tub, the rate of transfer becomes less, and we see that pattern. So if you think of it similarly, with our healthy population, our susceptible population, the number of susceptible people affects the rate at which people become infected. If you have lots of susceptible people, then you're going to have a higher rate. So that's why we connect this feedback. And there's one more piece of feedback I'm going to connect in. As more and more people become infected, that's going to affect the chance of a contact becoming infectious, right? So let me just set that relationship. An increase in infected people causes the chance of contact being infectious to increase about the same. And now I want to look at what we have going on here in terms of these curves. These should look pretty familiar to the kinds of curves that you've been seeing in the news, right? This is the total number of infections, right? It started off slow, then it accelerates, and it's going to plateau as we stop having more new infections. This curve in the middle represents the new cases each day, right? And when we talk about flattening the curve, that's what we're talking about, right? If we reduce the number of contacts, then that curve is lower, it's flattened. And so we don't overwhelm the hospital system. But if we increase the number of contacts, we get a higher peak of people who are getting sick all at once early on, and that could have that effect on the hospital system. I hope I probably just blew a lot of people's minds with with the detail.
That was very cool.
But I mean, the thing that you can see here, you know, you can see there's not very many variables in this system. And we worked through this without traditional coding or, you know, writing complex equations. and we could model a system that people are seeing in the real world, and we could see that it didn't quite match up. So maybe there's something missing from my system. How do I go back and think about how is my conception of this phenomenon different from reality? And one of the things that I really like about SageModeler is and this was mentioned earlier, it gives a student a chance to say, well, here's my conceptual understanding of this. I have a way to try it out. I have a way to instantiate it and represent it here on the canvas and see, does it match reality, right? And then there's ways for me to get feedback, because ideally there's some way for me to look at reality and say, how do I figure out, is my model, because if this mental model that I have in my head is well represented here, then I can get that kind of feedback. Now, it's not as simple, obviously, as that, because there's interplay between how they're thinking about it, which might be sort of vague, and how they know how to use the tool, and understanding how to use the tool. So it can get complicated, and the reason why we spent the whole first one, was on static, and we recommend people start with the static equilibrium models, is because they're much simpler. All right, so there's a couple of other examples in terms of dynamic systems. I'm going to show two of them, like 30 seconds each, and then I want us to break up into groups, and we'll give you some options for how to do that. Someone asked in the survey for a physics example. So here's one where we've got energy flowing through a system of a motor, and you can see here that you talk about F equals ma, so we have a V equals IR basically, and so I can adjust resistance and voltage to change my amperage, which drains my battery at different rates, and depending on the internal friction, I can shunt stuff more to environmental heat first or more to the motor. So this is one, again, we're not going to go through how to set this up, but if you're interested in dynamic models, you might want to try and pick this one apart. And then the other one was for chemistry people, since we've been doing all biology and earth science so far, two different ways of thinking about evaporative cooling. One would be the molecules as a collector, so liquid molecules becoming gas molecules, or one with being energy as the collector. So energy, thermal energy in sort of like if I had a drop on my skin, this is a model of dropping something on my skin and having it evaporate and feel cold. So then I would have a thermal energy in the evaporative substance and the potential energy in the system. And so I have two separate models on here. Each of them models this in a different way, but you can see different approaches. And again, at your own time, you should take a look at these if you're interested in the dynamic modeling. And for the person who did the thing with the acceleration and velocity, it's related to these kinds of things here. All right, so we're going to do a quick poll on what kinds of breakout rooms people want to have us generate. And so please choose, you can choose more than one, and then we'll pick a few of the most popular rooms here and make those. And
I want to make sure, can folks see the poll? I've launched the poll.
I can see the poll now.
Okay, great. Oh, perfect. Yep.
Yadna will break us into rooms and tell us what room she's going to make. Actually, how do they get into the room that they want to
So
eat?
I'm going to sort folks. I actually basically need to do it by name. So this will tell us which groups. Thanks, kiddo. The line. This will tell us which groups we'll set up, and then I'll just do a quick, you'll unmute yourself, I'll call on you, and you'll tell me which room you want to go into. Okay, so we got dynamic modeling, that'll be group 1. Basics is going to be group 2. Subject specific, group 3. Got a couple more people who can vote, but I think that might be some of us. So let's see. Hassan, can you unmute yourself and tell me which group you'd like to join?
Dynamic.
Great. Fernand. I'll assign him to dynamic also. He's our president.
Yes, yes.
Okay.
Dynamic.
Jackie.
Yeah, dynamic too.
Not surprised. Please excuse pronunciations. Maela?
I think she left the meeting.
Okay, Suzanne?
You.
You're gonna join Back to Basics?
Mm-hmm.
Great. Jay Wolf.
Yeah, back to basics.
Excellent. Alan?
I said subject specific, but if I'm the only one in there, I'll go with the dynamic group.
Which subject, Alan?
Physics or engineering.
Okay. Debbie? Maybe she left. Jenny? Sometimes folks step away. I have Alicia.
A6, please.
Great. Kamisha?
For me, the dynamic or the subject specific, specifically, what do you call it? Environmental.
Okay.
Either or.
Juliet?
If there are people who want to go into younger students, I will follow people there. If not, then I will go into dynamic.
Okay. We have one. I think it's you.
I don't think it's me. I actually think it's
okay.
so I'm more than willing to go into that room with that person.
Jenny is here.
I was gonna volunteer for younger.
Oh, yeah. Great. Okay.
Or basics, either one.
Okay. Let's do younger and Juliet younger. Okay, and Autumn? Oh, she's not with us anymore. Just one more try, Debbie and Maela. You'll be left outside of a group, and you can just tell me after the fact if you're still with us and you want to join a group. Okay, so next step, Dan, Tom, Emmanuel, Lynn, and Steve. Please tell me the groups you would like to join.
Why don't you put me in dynamic?
Great. Tom?
I'll do back to basics.
Great. Lynn?
Wherever I'm needed.
Okay, hold on. We have physics and a younger SageModeler for younger students.
I'd like to go in physics.
Okay. Would you be comfortable also working through an environmental science?
Sure.
Great. Okay. And Steve and Emmanuel, we need a younger students team.
Steve, I guess I'll do the physics. Is that the subject specific room?
Yep. Okay.
That'll be physics and
And put
environment.
me in younger.
Fernand, you want to do younger? Okay.
Yeah, sure.
Just with the from the Sage modeling team, Emmanuel, you are support work staff here.
Again, wherever I'm needed.
Okay, so we need a group for younger students. Okay, so there are 4 groups.
Steve, do you want to swap with me in terms of dynamic and physics?
It's okay. I'll do either one. Which I think we're probably going to end up doing dynamic in the physics one anyway. So
right.
All right, let's be organic about it. So group 1, you're going to be dynamic modeling. You're going to have to give me a minute to sort folks because it does random initially. Back to basics will be group 2. Group 3 is subject specific, focus on physics and environmental science. And group 4 is going to be younger students. Okay. All right. Bear with me.
Hi, Fernand. Nice to see you.
Yeah, nice to see you, Alan. Great to see you. You're looking good. You need a shave, but we all do.
Yeah, it's really grown.
Hey now.
Quick logistical question. It's a little after 5 right now. We had hoped to spend half an hour in groups since this is potentially the most precious time. Shall we just end in groups, or do we want to come back after meeting for some time?
I think we could come back.
Let's come back for the last 5 minutes. People can either ask questions or, you know, maybe we can share, each group maybe share a model or something.
Great.
Yeah.
Great. Okay. One moment. Oh, basics is group 2. This is interesting. We had it so well planned out last week, and we had pre-assigned and subject-specific groups labeled and everything. Younger students, Juliet and...
You're doing great.
Thanks. Juliet, Emmanuel, and who was the other younger?
Fernan.
Fernan, okay. Great. And breakout 4 is subject specific, and we have Lynn and Steve and Alan. What did you vote for? Yes, you did. Subject specific. And let me see. I'm seeing, yeah. Oh, Dan, I forgot to assign you to dynamic. Okay. And Jenny, where are you? You're with the younger group. Got it. Okay. So almost ready. Oops. Did I just add you to the? Hold on one second. Jenny is great. Okay. And wow, this is things I like about Zoom. Okay, great. All right, all set. We'll work. Sorry, Tom, you were saying 15 minutes?
So we'll end at 5:25.
Okay, great.
In 20 minutes.
Perfect. And you'll all see sort of a 60-second countdown, but keep an eye on the clock as well.
Okay.
Okay.
Did I get assigned to a group?
You did not. Tell me which group you'd like to join.
Physics.
Let's see. Tell me that is group 3. Is that true? Let's see. I think I can just drag and drop. Assign to group. 1 second. I don't want to drop you into the younger group. Fernan, Jenny, Juliet, group 4. Yeah, okay. Perfect. Hi. Sorry, I kept trying to like assign you to a breakout group and then it wasn't working.
I've done that, yeah. And then I leave the kid in the class, in the waiting room for like 20 minutes. I'm like, oh.
How do I view my breakout groups now?
Oh, I can join one. I can join group.
Yeah, go ahead. Which one did you want to join?
I don't know. What's wrong?
So Juliet is getting some pointers on her existing models in the younger students. Maybe you might want to join the dynamic group.
Sure.
The thing is, it says that you're already in it. It's very weird. This is very strange. Zoom is acting a little weird because it doesn't let. Okay, so let's see. Breakout 2 is beginners. I may pop you into 4 and then back into 1 because it doesn't register that you're already in 1.
Okay.
Okay, so apologies to group 4. All right. Nope, and now it says still not joined.
Oh, let me see what it says. Oh, well, now I can join it. It does. It
Hold
did
on.
change.
Oh, it did? Okay, let
Yeah.
me see that one. Okay, let's see. Okay, so put you in 1. Lynn Steven in Brigham asked for help. Okay, I gotta go to group 4.
All right.
Okay, are you in 1?
We need more time.
I know, it's always like that. It's somehow,
Yeah,
it's like
me
somehow you mentally know that how much time you have and the conversation is always the best in like the last 2 or 3 minutes, no matter how long your session is.
Meanwhile, I thought I lost my signal because suddenly everything disappeared. And I was like, wait a minute, what just happened?
It's the magic of Zoom.
So we probably don't have time to do a lot of sharing out of specific models, but maybe if people had questions or comments at the end that we could address, or just feedback?
Well,
No
well,
pun intended.
in the youngest group, we had a tour de force. I mean, these fourth graders generated three or four different models that were really quite impressive. Not all of them had functional relationships, but they all had logical connections, and that seemed to stimulate them to think about it.
Yeah, any kind of tool that gives you a window into the students' thinking can be really critical for understanding where they're at and helping them move forward, or them, you know, work with each other to help each other move forward.
Yeah, it also it indicated that students thought differently about certain things. You know, drought. A couple of them did drought, but that models were very different. You know, in the way they developed them, which is, to me, is terrific.
Any other questions or comments, feedback?
More time. I want more time to work on these things.
Yeah, I'm just going to say to Alan and Jen, I'm putting links to models of an oscillating spring and acceleration, velocity, and position. So you can take a look at them, try to figure them out. Okay.
And I will put in the agenda a link to that final epidemic model. So if anyone wants to dissect it or play with it, I know that was very quick as I built that, but I'll put it into the agenda so that it's there for everybody.
I think actually Autumn did paste a link to her video a little bit sort of halfway up the chat. That document will be open and is yours to work with from here until however long you need it. And we will likely reach out to folks who attended last week and this week to see where you would want to go, general feedback, and what you're working on. So you will probably get an email from me in the next few days. We really want to thank Tom and Dan and Autumn and Juliet and Lynn and Steve and Emmanuel for walking us through this, making the time. I feel like the breakout groups, we had wanted to spend more time on that last week, and we really got to do that this week. You know, never enough time. But I think there were a lot of good conversations and a lot of great things were started. So please do share those if you feel like it in the doc.
Yadna,
yeah.
I think someone in my breakout group asked, you know, that building that epidemic model in terms of the dynamic thing. I did try, and I went a little fast, but I know that you're recording this. Is it possible for people to get access to the recording?
Oh, absolutely. That's right. So all of our recordings are available on our virtual resources page. If Dan would like to give a last word, I can go and find the link and drop it in the chat. That's where that will be housed.
I just wanted to thank everybody for coming. I know that there's no replacement for face-to-face professional learning experiences, and that this can be a little challenging to do online. That's part of what we're exploring and trying to figure out how to do. And I really appreciate everybody taking the time to come, learn a bit more about SageModeler. In the previous session, so the agenda that's up above, if you look in the agenda and you scroll up, you'll see there's a whole lot of actual other resources that we have at the Concord Consortium that people might find useful, and also my contact information in a way to sort of stay in touch if you want to find out more information about what's happening with SageModeler and other things at the Concord Consortium.
And I'd be really interested in hearing results of discussions that you have with students, any discussions that get stimulated by these models, any productive techniques you find for discussing discussions that are supported by the models.
So Lynn, if you want to put your contact information in the agenda, then perhaps
I'll do that
with a note about.
Thanks, Juliet.
Yeah, I think you know, there's a lot of potential for this modeling with students. As Dan said, you don't need equations, you don't need graphs, you just need relationships, and kids understand that. So I think we could run some workshops on this if we, have some expertise to help us out. We still aren't experts at it, good enough to lead a workshop, but I think this could grow very quickly. I think New York would be a fertile ground. I think they're looking for something. They don't know it yet, but I think they would be very interested in something like this in New York. They're all tied up in the CS. Everybody has to become a programmer, and et cetera, et cetera. This is really down to earth and really concrete. It's nice.
Yeah, the one last statement about related to that. This is funded right now under an NSF program called STEM plus C, with the C being computational thinking. So we feel like this is a great tool for learning about modeling, for thinking about systems and systems thinking and computational thinking. You really have a lot of opportunities to engage students from different perspectives on the kind of work that you do with them.
Yeah, it's really fantastic. It's really exciting, and we're happy to have started this conversation with you and with the group here and the group last week. So it sounds like it's not a goodbye, it's a see you later. So we will be, you'll be hearing from us, and hopefully we can continue in some way in the future. So with that, a big thank you to everybody who is here.
Thank you, everybody.
And thank you to STEM teachers in New York City for hosting this and getting this to happen.
Yeah.
Really keep up the good work. It's great stuff going on there.
Thank you.
See you soon.
Thank you. Bye.
Yeah,
Bye.
thank you.
Bye-bye
Really
now.
good. We appreciate it.
Bye bye.